Here we will see explicit typecasting with cast operator in C#. If you want to convert the large data type to a small data type, then you can do this explicitly using the cast operator. This type of casting is known as explicit typecasting because you must write explicit code to perform the typecasting. It includes the conversion of larger data type to a smaller data type. In case of explicit conversion or explicit typecasting, there is a chance of data loss or conversion might not be succeeded for some reason. This is an unsafe type conversion. Here we explicitly convert one data type to another data type. Typical examples include numeric conversion to a type that has less precision or smaller range and conversion of base class instance to a derived class. For example, the larger data type like double or long which have large memory size are converted to smaller data types like int, byte, short, float, etc. which have small memory size. Explicit conversion or explicit typecasting in C# is done by cast operator. Here casting is required when information might be lost in the conversion or when the conversion might not succeed for other reasons. We will get compilation error when types are not compatible with each other. For example, if you have defined the variable num_double of type double and if we assign it to integer variable, that is int num_int equal to num_double, it will generate an error as cannot implicitly convert double to integer. For this, we use cast operator for explicitly converting one type of data to another. For example, here we have defined a variable num_double of type double, and if we want to assign this value to an integer variable, we will explicitly convert it using casting operator as int num_int equal to, in bracket we will write the data type in which we want to convert the variable. Since we are assigning this value to integer variable, we will write int num_double. Now we will see this explicit conversion in C#. Here we will define three variables, one of type double as d1 and we will assign the value 456.54 to it. Then we will define integer variable i1 and we will assign this d1 to i1, but it will generate an error. We will check here the error. Cannot implicitly convert type double to integer. For this we will use casting operator here. So we will use here int d1. Then we will define byte variable as b1 and we will assign this d1 to b1, but again it will generate error. So we will convert it to byte. We will define another integer variable c1 in which we will assign 32 and we will define a character variable c11 and we will assign this c1 to this. Here also it will generate error, so we will convert it to char, so char. And now we will print these values. So console.writeLine will print value of double variable d1 and we will print d1 and then we will print data type of this d1. So console.writeLine we will print here d1.getType. Then we will print value of integer variable. We will print i1 and then we will print data type of this i1. So i1.getType. Then we will print value of byte variable and we will print data type of b1 as b1.getType. Then we will print value of character variable as c11 and we will print data type of c11 as c11.getType and we will execute this. It will print value of double variable d1 as 456.54 and data type of d1 is system.double. Then it will print value of integer variable as 456 and data type will be system.int32. Since i1 is an integer variable, it will truncate decimal points and it will assign 456 to i1. Then value of byte variable will be 200. Since byte variable has low precision, it will truncate some of the data and store 200 to byte variable b1. It will print all the values, but the value of the character variable is blank since 32 is ASCII value for space. To check it, we will assign here 65 and we will execute this. So here value of character variable will be a and the data type of this is system.char since 65 is the ASCII value for character a.